Welcome back, guys. So, where did we leave? Uh, yes, we were trying to debug the issue where the entire linker script fucked us, and now I've written a bigger command this time. So the whole issue was that all our functions has to be placed under this, and it was overwriting this data. That was just the issue, and we had to align it properly so that will never have to will never overflow this block. That was the issue, and we fixed it, and we got the green signal. That is, we were able to print stuff properly. We could see it in action just to be sure. And let's build it and run it, and it's working fine, so that's good. Now we can remove this one, and let's write it, and let's come back, run it. That should be good. Yes. Now let's now let's do our stuff. That's this. We have to do what? Yeah, we have to call this diff. First of all, let's just confirm if we have commented out all the things in MMU, and all our new functions are there. The new functions that we have written are the main allocate mem that's gonna create new pages, and we also have that's a helper that's going to set the page table entries for them, and this is the higher level helper that's just going to call the malloc allocate memory and then create the page table entries and return the top of the page, and it should be good. Let's go to our kmain, and let's see what do we have here. We need a bitmap, and it will be used by the allocate mem. So we'll create a new allocate mem. We'll set the buffer. We create a bit index. We need this because every page table we allocate is a bit index. But I think, do we need it really? No, I don't think we need it. Because we masked everything under, we encapsulated everything under kmalloc, right? You're not supposed to pass anything. That's the whole point of having a high level helper, I believe so. Yes, we create our own bit index, and we pass it, and we do some random stuff, and we use it here. So yes, do we not need the bit index? Right. We do need the bit index. So maybe we don't need it. Let's see if it works first of all. So we don't need we need allocate, but we don't need bit index. And let's rethink this, and we'll create jar buffer. I think I don't know if this step will work because I know this will work, but I don't know if this will work. I guess we might need to manually select the arrays and set this, and let's print it. Now if we come back here and build it, run it, we have total RAM as 0 and total bitmap size is 0. That's not good. Why do we get total RAM as 0? Ah, I just remembered it because I remember the fix that we left off for the final part. There is the where is it? Start as, yeah. We did some crazy stuff here, but actually what we need is we move x13 into x0. Let's see now. What the fuck? Oh, I have to change the operation. Move. Okay, now we have the total RAM. We have the bitmap size. Okay. What are we trying to do now? Let's add more print messages to see where we are stuck and what the hell is happening there. Because let me just explain what is the fix I have added. It's just that previously, as I mentioned, we are calling get total RAM here and we are storing it in x13. That's why, and we are hoping that these three operations won't overwrite x0, and then we just move it to x1 x0, I mean x13 to x0, because kmain first argument is the total RAM, and to pass the first argument you just have to set x0. That should be good. Now let's see. Now if we come back to kmain, and we might have to add a bit more print messages because it will be hard to debug. Let's add one here, and I think we have LU format descriptor. Hopefully we have L, yeah, it's L. Pointer %L test. Let's see if we even, what the fuck did I do? Let's see if we even have it allocated properly. Maybe something else is going wrong. It's definitely possible, because okay, so we never reach that point of the code, so we never reach here, but we have passed this point. So let's just say allocating memory, and we can print bitmap. Okay, okay, so allocating memory works. This is just a very big 64-bit integer because it's an address, and also we start from FFFF, probably that's why we have this. I don't know, well, we'll see. Let's go into now, and as MMU, let's also just copy this UART because we might need to add more and more. Let's see if mmu.h has it. No, it doesn't. Maybe we could just add it here. Add here, and if we come here, and we should be able to print some stuff and see what's going wrong. Let's see. Let's try it here first of all. uart printf. What do we have? The total allocated. I guess it's possible that this line is not working because I'm just creating a pointer, but there's no real space here. Probably this is the issue. We might have to allocate it in stack and pass it and then do the stuff. Let's see. L total allocated. We could also potentially print this. Res. Let's see. Okay, see, as you can see, res is just 0 because we have allocated it as 0. Okay, let's change that to, let's say, 64. And I guess the first index will already be passed, so we don't have to change anything there. What is the errors? Why do we need memset? Did I call memset somewhere? Let's see. Memset. I don't have any memset. What do you mean you want to allocate memset? Maybe it just does not like this operation. What does that has to do with calling memset? Okay, so we have a stack allocated variable, and now we have the actual mem. Wait, in that case maybe the mem is also not valid. What is allocate main? Allocate main is just a pointer to a structure called allocate main, and it has a buffer that is also a pointer, and that is allocated in our separate block, so it should be good. We don't need anything special here. It should be good. Let's just get into allocate main, and let's get into, if it's less than, we should be in this condition. If we get here, let's print what is this fucking size. uart printf of size in set bitmap %L, and its size. And let's just run it. Why is this too big? If maybe my format specifier is wrong. Let's try to convert it into an integer and try it. Even now the size is some big value. Where do we get this size? Size is an input, right? Yeah, I am passing size, and the size is just 300. Maybe that's the issue. I have to create a uint64 t psi equal to 300 si. Let's try. Nope, still something else is wrong. We get here. Where's the kmalloc? Where is the kmalloc? Okay, here's it. Here it is. And we have the allocate mem. Oh, it takes two variables. I'm so fucking fucked up. So we can pass allocate mem and it should be a address, so we pass the pointer to it, and there's our signature fucked us up. Allocate mem pointer. That's why you should not just randomly allocate it. Let's put it here. ALLOCTD. Dude, you fucking... Okay, I have to construct XDR. Okay. It should be good. It should be good. Okay. Did we actually make it work? First of all, I can't believe that. So let's just assume that it's not working. It actually worked? Fuck me. No. Maybe it's just taking it from here. How do we know it's actually stored in that? Let's try something different then. Let's try this approach. Because this way we know that it should be stored in the actual location that we tried, and we make it as const so it won't work. And let's try this. Even faster way would be in the I equal to 0 I plus I or I plus plus. I guess it's I plus plus. Then we can just... Oh fucking hell. And we can and it should be for I don't think it will work because UART expects a const jar. See, it didn't work. I knew it. It's too good to be true. It's too good to be true. But we also maybe have to confirm one thing, because it should be a const char. Maybe that's not working. Okay, let's just check if this is there in GDB. We should be able to see that, and we should be able to see where exactly it's there. Oh my fucking god. Now if we do this and let's disassemble UART printf and take the top of this and b star that and convert this into 4f's, and now if we try it, we stop in the first location, we continue. We have faulted somewhere. Cannot access memory. Last time we have allocated one. Interesting. What's the better way to debug this fucking thing? We have to stop here somewhere. Then we can step one at a time. You could simply write a dummy function and make it load there. Void test me void UART. No, if I put UART, then I have to go through entire UART. It's a fucking nuance. I don't want to do that. Let's just put I equal to we'll just put int return 1 plus 1. That's not a function, that's just to hopefully my compiler won't optimize it, because if it does optimize it, then there's a big fucking mess. It's a big fucking mess. Let's try. Let's try. What can we try? We have to call that here. So int 32a equal to test me. Now we can break at test me. hopefully we can break it. Test me. Disassemble, test me. Okay, we do have it. And we paste it here. And we change FFF. And we should be able to continue. What the fuck happens? Oh, we are at the breakpoints. Okay. What happens? If I try to disassemble, there's no function frame. Okay, if I SI. So I am somewhere. I am at this location. And then we could just say instructions at cannot access memory. Why? But still, I'm able to step past. Okay, and then I'm reaching vectors. Vectors then means I am in a fault. Why are we not able to access this? It's just 8,000, right? We should be able to access it. First of all, there is no issue, right? Because if I just press this, I'm able to reach till this point. Something is wrong. Something is wrong. We have test me. We have this pointer which is already does not look that good. This is a pointer and this is a pointer, and I'm assigning that pointer to this pointer. If I had actually added the table entries, it should be accessible. Maybe that's the issue. We're not adding table entries. But first of all, we have to confirm one thing. What's in this? We have to know what is in this. How can we do that? We should be able to do it by do this and disassemble kmain, and where do we call kmalloc? Yep, and we just have to stop here. And star and put 4 F's in the front. And if I run this, Oh, okay. Looks like we are not printing this pointer. Did we actually print it in a normal run? Okay, we are printing it. So it is working. Somehow it is working, but I don't know how it is working, because my GDB says that I have no clue what this address is, bro. What the fuck is this? That is what it's asking me. Uh, let's try. Cannot access memory at 17C. Why? But we should be able to access it, because it's just 8,000. If we access 8,000, it should be going to 80,000. Yeah, nothing much. That's all I ask it to do. Maybe it's something issue with GDB. Maybe we are not even supposed to debug this. But if we don't have debugging information, info registers. How exactly am I gonna figure out which address was assigned for me? Let's see. If we build this and okay, right now there won't be anything. Okay, fine, that's fine. Break at this point, and I put info registers x0. I think I have got the correct value, because I think when I first call this method, nothing will be allocated, so it's just going to give the first memory location. That will be the 0th page, and it has added mapping, so it will be from actual 0th page, but we have FFFs in the front. So at this point the locate should have been done. So if I access this, I get access error. Maybe I'm messing up my table entries. That I believe that is what is happening. Because of that, my MMU is having hard time understanding what the fuck did you do, bro. That's my map. Let's do this. Let's just comment this out, so we don't actually do any mapping. Now if we build it, and if we stop it here, and if we run it, see, now we still have the entries. So this is the actual issue. We are messing up this part. Okay, so at least we know what we are messing up. That is always good. and we should get the error because we don't have any mapping. Let's try it one more time. We kill it, we run it, we stop at this point, we continue, and we just came back here, and the x0 value should be the where is it? Yeah, the x0 value should be the pointer that we need. So it should be x0 and it's fffff0. And now if I try to access this memory, it would just say can't access this memory because I don't have a page table entry for it. Okay, now everything is good. Now we just have to fix this one helper. Where is that damn thing? Okay, what do we have here? What exactly do we do here? We try to take an address and map it to we are generally doing identity mapping, so we take a virtual address, and we also have the total, that is how many virtual addresses we have to map. So if we only want to map one, then we go through it once. So what we do is that, let's uncomment this. Let's uncomment this. If we uncomment this and if we try asking, well, it's simple arithmetic operation. So we have the VA, we add 496 to it, that is the what's it, that's the page size, page size, into 0, that is because we have multiple pages that we want to add the page table entries for. So in this case I will be 0, so we have to add a page table entry for 0000, and let's just write it down. So we have an anchor point. What the fuck? Input VA will be 0x 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. We have to map this to 0x f 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. Okay, this is what we want to do. So we get the PA identity. So this is our virtual address. We want to get the physical address. Oh, fuck me. Fuck me. This is the virtual address. And we want to map it to physical address. 0x 134 134 134 134. So this is our virtual address. We get the physical mapping. It's just a simple macro. What it does is that we just add FFF in the front. Nothing much. It's super easy. Oh god. And we get that. And now we have to add a L1 entry. What does L1 entry mean? Because there is no L0 entry, because we always the first 512 GB is already marked as a table inside our L0. So we don't have to most part worry about L0. So for almost everything we only have to care about L1 and L2. So in L1 we have to find the index within L1. So we calculate the index for that. We create a table descriptor. Why do we need to create a table descriptor? Oh, okay. Yeah, we need to create a table descriptor. I think this is where we fucked up. I think we have to give the L2 tables address here. I think this is what should be here. And we get the table descriptor and we set the value as in within L1 base within the L1 base within this index, no, in L1's table, this index, this value. So we calculate the index and we calculate the table, and the table should be a L2 base. Yes, and it's a L2 table. And now I have another question. What if I'm reusing L2 tables between different indices? Will the L2 table have enough indexes? Or do I have to create a separate L2 table for this? Maybe it's better to create a separate L2 table, because how do we do it in the main MMU? Because in main MMU I am creating three tables. I have the L1 table, I have the L2 table, and I have the L3 table. That would be just the L0, L1, and L2. And I see here I'm adding the L2 tables base in the within the index. And for within L2, there we actually add the physical base. I think we might have to create a separate L3 table. Yeah, I think so. Then we might have to create lots of L3 tables, because for every index we might need a different L3 table. That is to say, how do I put it? That's it. Yeah, for let's say for this address, the L1 index will be 0. So for the 0th index, I need a separate L3 table, and for the first index, I need a separate L3 index, L3 L2 table, and for the third index, I need a separate L2 table. So I guess I need to create separate tables. And there is around 512 tables. Do I actually need to create 512 tables? Wait, I have a question. So let's say I have an L0, L1, L2 tables, and I am writing table descriptors in L1 indices. Can I share the L2 table between all L1 indices in page tables? I think it's not possible. I'm just asking this dumb fucking question because I want. Oh, we can? Wow, how? So we have a 4 KB page table, and L0 points to L1 table, and L1 points to L2 table, or a block, but in our case it's all tables. And L2 points to L3, we don't have L3 table, leave that. Yeah, this is what I'm asking. L0 has to point to a table, L1 has to point to a table, and L2 has to point to a table. Same physical L2 table, yes. Architecturally, MME does not forbid it. Yes, that's fine. I know that we can put it there. I'm asking what if we overlap indices? L2 covers 1 GB. L1 covers. Then it's wrong, right? Because if this index and this intentionally aliasing, I'm not doing intentionally. I think this is wrong. Yeah, this is wrong. I don't need this functionality. I have to create separates. Okay, that's good. Well, we figured one issue. So what we have to do is to do create separate L2 tables for every index. Okay, now let's see. Now we need an actual address. Then I need to actually know how many indices, uh, how many indexes. I think it's L1 table has 1 GB. So it's how many index? Hmm. So how many L2 tables I have to create? So I have to create 512 L2 tables. That's a lot of memory. That's a lot of memory. That's a lot of memory. Okay. Mm, that's a lot of memory. How do I keep track of it? Where do I put it? I have no fucking clue. First of all, this table has to take 2 MB of memory, I guess. So this L2 table has to take 2 MB of records, right? Then how many mm, how many entries and how many size should I keep? So L2 entry can have also 512 entries. We are going to map it as a block descriptor, and size of the L2 table itself, it should be, so a L2 table should be like this, huh? A single L2 table to be like, should be like that, and I need 512 into this. Is that good? One L2 table covers 1 GB. Now I'm fucking confused. So I have L1 index. Every index should have a L2 table mapped. So my L1 will have 512 tables. So if the size of an L2 table is 512, then it's 512 into 512, right? L1 has 512 entries. Each L1 entry covers 1 GB block. Okay, that's good. And each entry, in my example, each entry is going to point to a L2 table. That's good. So each L2 table entry will have 512 entries. That's also good. And I don't know, map this. entry save type. Okay. How many L2 tables do we need? L1 should have L2 table map, that is 512 entries to 512 table entries, correct. Okay. Size of one L2 table is 4 KB. Okay. All L2 tables would only consume 2 MB. Yeah, so some big entries. In memory usage sense, one L2 table is 4 KB. So 512 into 4 is just 2 MB. Huh. Then it's fine. I thought 512 into 512 will just seems a really big thing. Yeah. Okay. Then it's fine. 512 into 512 is just 2 MB. We can spend 2 MB. That's fine. That's fine. So now we have to. Okay, we have to add that. How are we gonna do that? Where is it? This is our existing tables. And this table is our key table that will be stored in the register. Also, let's just limit it to first two entries because we don't want to allocate the entire thing. We do get its size, but yeah, if the size is greater than 1, we are gonna just print a message saying you are print, you don't have that much RAM, because zeroth index has 1 GB, first index has 1 GB, so that's like 2 GB of RAM. That's enough. Oh no, we have to do this in the here. This total. Okay, that should be good. Now only thing we have to do is we need two more indices. Let's create two more indices. Where is it? Holy fucking moly. And this will be L201. How do I... Zero one, and it would be 8,000, and this is 10. Hopefully I don't have anything here. And let's see, what do we have here? Int 64 current L2 equal to I equals equal to 0. Then we take L1, else we take L1, and we put that here. I think it should be good. Nothing much. Maybe. Well, it won't be that flexible, because in case if we want to add more RAM, then we'll have to improve this into a dynamic thing, and we also have to allocate this into a dynamic thing, because right now we are using static values, that is these two, and these everything static, but I think it should be good. Let's see, let's try, and let's get into let's break here and let's continue. We still don't have proper mapping. Why is that? Wait, let's think. We have an L2 base, and in that base we we create a L1 index with the we find the index, and we make the table descriptor for this L1 physical base, L2 physical base. And then we set the entry in L1 base, maybe we should convert We also have to add the physical kernel base for that. I get it, I get it, I get it. Because we need two entries. One is for the VA to PA, and we also need PA to PA. Why do we need PA to PA? That's for that case where as soon as we enable MMU, we won't have that issue. We'll have an issue, that's why we needed that. But here, why do we need it? Because we are trying to allocate something after we enable MMU. So we do need this. Yes, 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 we need it. Let's copy these lines, these three lines, and if we come down to our mapping and we can paste it here, and we are create for this VA, we are creating a entry in the physical physical L2 table with this value. For this PA, we create what do we create? In current L2. Shit. Current L2. Okay. We create an entry for this pointing to this. Now we create another entry that is this pointing to this. I don't know why. I'm a bit confused. But let's see. Let's see if it works. Why do I need this identity mapping? Maybe I'm trying to convince myself to just to test this. If it works magically, then we don't have to worry about it. Okay. What about the L2 entry? Maybe for that also we have to create two things then. Let's just use this. For current PA. Make a block descriptor of PA and add it. That's it. Hopefully it works. It didn't work. I'm gonna fucking kill myself. What the fuck is this? Let's just remove the QEMU log. It's 0th log, I guess. let's just remove every damn thing. And now if we run it, we should at least get some idea of what the fuck is happening. Now if we go back here and if we open that QUMU file, yep, now we should get an idea of what's fucked happening. Not this. If we go to QMU1 and if we go to the fault, where is the fault? There is no fault. Oh, there is fault. And it starts right here. Oh, it starts here. No, almost there. It starts here. No, it does not start there. How does it start? You're fucking with me. Ah, it starts here. Okay. And we get the corruption for this address. I think we are getting an L1 error. Huh. Looks like that because it's 4. Or do we have to take this? No, this is the address. This is the L1 error. I think it's an L1 error. Let's copy it. No, L0 error. Looks like it's L0. See, it's a L0 page table entry. But L0? Why do I need an L0 entry? I was just bragging saying that L0 must be already assigned and we should have enough for 512 GB or something. Because let's go back here. Where is it? Yeah, L0 is like 512 GB. Or maybe it's because FFFF. How many indices are there in L1? Okay. So the total is 512. So. Oh, fuck. I'm doing something wrong. No, I'm not. I'm doing something wrong logically. Technically, we are adding page tables, that's fine. But logically, I'm missing some information. Wait, let's trace back to where we started. What do we want? We want to allocate new page table entries. Why do we want new page table entries? Because we need new memory. And let's say we start off I'm trying to access which entry? I'm trying to access this address. Why do I need an L1 entry for this? Let's see, L0 entry for this. Okay, I am using. Let's backtrack a little bit. A normal MMU will have we needed the mapping from 0x8888. Oh, okay. Now I get it. But. Yeah, but virtual memory is in virtual memory FFFFF is possible. But for physical, we should not give FFFF. Am I giving FFFF in physical? No, I'm not giving that. See, I'm taking a virtual address that will be this, and I need to create a table entry for it. And its physical address would be PA, which is just 0000. Right? Oh, fuck. I get it. I'm saying here, take the virtual address and R it with FFFF. What does that mean? It's just going to keep the FFFs in the top. I think that's the issue. A physical address should be 0000. So I have to AND it. What the fuck should I do to get a physical address? I have a virtual address that is FFFFF and this. So I have to AND it with 000. Ah, okay. I know. I fucking know what to do now. But the issue is, I think I'm using the same thing inside here. Here I'm doing this. This is correct because I'm taking a physical address and I'm adding it to converting it into a virtual. But when I do this, I'm getting a virtual address and I have to convert it into PA. In that case, what I have to do is I just have to AND it with 1 2 3 4 1 2 3 4 1 2 3 4. This is what I have to do. What the fuck did I think I've given it like I'm doing some shifting operation, but there's no shifts here. What the fuck, bro? Maybe I'm dreaming and I'm writing things. I don't know. Well, let's see. Then now we should not be accessing that physical address. Let's see. Okay, we do have an error now, but at least let's see if it's not an L0 error. That would be a good thing. Where is it? Let's remove this first of all. Let's remove this file. rmq, remove it, close it, and run it again. And now if we come back and if we open that file, we have an error, and it's we have to go a little bit top. Where did we get the first exception? That's what we need. But finding that is a big trouble. I think it's here. Oh, we still have L1 error. Fuck me. We still try to get this FFFFF0. What the fuck? Where is that? Why am I trying to read from FFFF? What the fuck is wrong with me? I convert it into PA. Now I have the virtual address and I pass it down to here, and I'm trying to convert it back into convert it back into PA, which would be this. And what do I do now? Now I have to calculate the index L1. How do we calculate index L1? We just do some shift operations. Fine. Fine. And we make table descriptor out of current L2. And then what do we do? We add that entry to the physical address. This is a physical page. And we try to calculate the L1 index again. L1 index of PA. Make the table descriptor set the value. This is correct. I don't think there's an issue here. We are missing something else. And we calculate the L2 index for current VA. And we set it. I think this is fucking correct. What we didn't get is somewhere else. Let's dig deep into the log files. What was the final instruction that we tried? As the instruction. This is the one. This is the final thing we tried. What the fuck is this? Let's just see. We'll try to run it. And we'll put B star this. And we can run it. Okay, just because I'm here, I have no idea. I still have no clue. What function is this? Disassemble. What can I disassemble? Maybe map. Page table entry. Oh, this is not. Well, let's just go one step at a time and see what the fuck stops us. We have a function call to this, and we go there, and we don't take that. I have no context of where we are, so it's impossible to judge. Nope, it's not helping me in any way. Let me just disassemble different functions and come to a conclusion of what that might be. No, it's super simple. I just have to change this to 0, 0, and I should be able to get it. I'm inside UART. Okay, that's fine. And I'm in start of a new UART. I think this is what I'm trying to do and I'm getting an error. I think if I stop here, then the x1 value should be the we're here, so let's check info registers x0. So this is the pointer. Now if we take this and if we examine it, how do we print characters? I guess it's C. No, maybe it's yes. Now it's getting printed because I am in the first printf. We have lots of printfs. Why do I keep coming to the same thing? Oh shit, I should have. Cannot access memory 80003081. We reach the first statement and we continue, and we reach the second. And 7. Still that. And we reach the third and it's C0. And we are in total RAM, okay. And we reach 26. I get it. We are using this memory location, but that location is also used by my page table entries. See? That's why it's fucked. Shit. Wait. Is it really that? Let's just confirm it. 1 2 3 4 1 2 3 4 1 2 3 4 and 1 2 3 4. Yes, exactly. And we have already overwritten our L1 table because there's L1 is in this location. Simple solution would be to put 2 0 and put 4 0 and put 6 0. and put 80 A0. And we also have to fix one more thing, that is my linker script. Here I'm starting from A0. Let's start from F0. Hopefully things will get better. It did not get better, but at least let's see if at least let's see if we have a better error. And if I build it, run it and kill it, and if I come to QMU, and if I find the error message, okay, to manually scroll it down to that starting point. It's annoying. I have to find some grep command to automate this step. It's fucking annoying. Oh, we still fucking have a L0 error. And we are trying to read this. Okay, let's try to step through it and see what's happening again. We continue, and if we print the first one, and if we 70, I think we could just do x0. Yes, we should do this. We continue, we press, holy fucking moly, and we press, wait, can we put x, yes, x0, and then this. How do we run two commands at a time? I think it's impossible. I don't have the patience to fix that. Let's just do we have continue, and we have info register, and we have this. Okay, we put continue, info register, and we put this. We continue, info register, and we put this. We continue, info register, and we put this. We continue, we put info register, and we put this size and bitmap. continue info register and we put this continue. Okay, the next continue failed. What was the last continue? After total allocated 1. What is total allocated 1? I guess I'm still messing up this stage. This is what I'm fucking messing up. No, this is total allocated. And then we have some steps in between. Let's confirm that. For VA and I did get pointer. I want to allocate page tables for it and yeah, I am gonna return that pointer. Okay, so right now we are not we are able to reach pointer too. Okay, so where's pointer? Where's pointer? Pointer is here. Okay. Then let's see if I'm able to come here. Pointer and it is name. And if I run it, okay, that step also did not fail. So this fucking step is failing. Why does it fail? Because we are trying to read an virtual address and that virtual address does not have a level 1 table. Maybe so far everything worked because we had a L2 entry and everything else is stack allocated and our stack is in our stack starts from 0 0. Maybe that's why. Okay. In that case, let's add the L1 entry. Let's add that damned L1 entry. L0 entry. So this is what we have to add. No, it should work because generally if I try to access this, well, we could do one test. We could simply try to access this. Char PR equal to char star 0. We're just simply trying to access this memory location. If everything was correct, we should be able to run it. There won't be anything there, but at least we should be able to run it. It's failing. Oh, so we never had it working. Fuck me. Let's see what's the error. Let's try something interesting so it will be easy for us to 3 4 1 2 3 4 1 2 1 2. Let's read from this address. We bash and we press C and no, it's working. See, it's working. So it was fucking working from the beginning. We should be able to access these addresses because we have added, because it's just a fucking virtual address. We could do one hack. It's just that because we are only using it after MMU is enabled, why can't I just put no, that won't work. I'm fucking stumped. What's this? Okay. We have an L0, we have an L1, we have L2, we have L0 base and L1 base. Now what are we trying to do? We have entries for and we are actually adding an entry. We are adding an entry for within L1 base. Within L1 base, we are adding an index and a descriptor. Within L1 base, again, we are adding an entry for physical to physical identity mapping, but we are only accessing this. If we are accessing this, we should be mapped to this. And we have the L2 entry for current virtual address, and we have the L2 entry for current physical address too. There's the identity mapping. Let's try one more thing. Is it when we try to access this, or we try to print it? When do we get this error? When we try to access it. And we get a What do we get? It's just that we are getting L1 error. That's what I don't understand. We're trying to reach this code. No, this is the address that we are trying to reach. From this code, we are trying to reach this address, and we get an L1 error. No, L0 error. How is that even possible? There's no entry for... And we also tested it like this. Here I am accessing the similar case, and it works just fine. This is the address. This is the only clue I have. And I can see that we're trying to access the address and we get a fault saying that this memory address does not have a page 0 entry. What does that mean? That means we need to add a page 1 entry. There's page 0 entry. Page 0, fucking page 0. How do I add an entry that's already there? Because when I enter into kmain, I'm trying to access a similar address and it's just there. But when I try to access that particular entry, I get an access fault. Let's think about it. We have a virtual address. We convert it into I get it. I have the L1 address and I'm saying that L2 is a table, but I'm writing into the old L2 base address. Shit. Hopefully this is the issue. Fuck me. Well, let's see what's the error message now. At least if we have a better error message, we can feel a little bit better. No, I still have the same fucking error. Wait, we could do one thing just for the sake of doing it. We can remove that 4 files, run it, continue, enter, come here, here. Oh, we still have the same fucking error. This is the L2 table. Within that L2 table, I'm adding an index and I'm storing that. It's not hard coded, right? Yeah, it is going to add it properly. Maybe we just have to clear the table once. L2. Let's see. Let's see if we have any luck. Nothing at all. Nothing at all. We don't have any fucking luck. We get the same fucking error. And it's an disgrace. But the thing is, right now it did not jump into what's that? Did not jump into the vectors. If not, it usually we get once this error and we jump into vector table. Now we just keep fetching the same thing. Do we have to do anything else? We only store L0 base because that has everything, and we have the L0 base entry for virtual kernel is wait, we have a L0 index for this. We can do one more testing. That let's just access this. We should get L2 error, not L1 error, because L1 should have this entry. We are expecting an error, but L2. No, L1, not L0, because right now we are getting L0 error. Okay, we got the error. Now let's go to QMU. Yeah, we are getting L2 error because L1 is there. We are trying to access this from this address and we get an L1 error. It's 05 because the first index is there. But how the fuck? Create the table descriptor. Within L1, we store it within that index, the descriptor. And for L2, we take the same value, we create the actual physical kernel base as descriptor, and we store it. Maybe this descriptor make table entry is not good enough. We have the table. We are taking everything else. It should be wait. We take, what is it as table descriptor? We have to only care about 47th bit, I guess, from 47. The rest is not needed, so we keep the upper bits and we keep every other bit, we set every other bit to 0. I guess that is what we are trying to do here. That's why we get this big long value. Let's do this operation. Let's test it. Let's fucking test it. Let's get into the fucking Python. Holy fucking moly. And we want what? Initially we are trying to do 0x 1 2 3 4 and 1 2 3 4 and 1 1 2 3 1 2 3 4. This is the initial address. We do this 0x f f f 1 1 2 3 4 1 2 3 4 1 2 3 4. Now we shift it to 12 and then we shift it to 12 right side. This is what we get. How can I hex it? Can I just hex? We get this. This is the value we get. And if we trying to find the index, how do we find the index? This is where we find the index. To find L0 index, A equal to, let's keep this. Now we need to shift A by 39 bits to the right and then and it by 0x1 ff. See, it's just adding it to the 0th index. Then how come even if I put 0, it should be the same 0th index? Oh god. See, something else is going on. Maybe we are overwriting something, because either way it's just 0th index. And if the 0th index is already marked in the beginning of the call, at this point there is an entry for 0th index, and when we reach here the 0th index is gone. Then probably we are fucking overwriting it somewhere. That's the issue. Where's my Mew? Mew. Yamamew. But here we don't even touch the L1 index. That's the thing. We never touch the L1 index. And the L1 index is around where? It's here. Why the fuck do we even change that? How the fuck do we even change that? That's impossible. Because that's why previously it was in here, so maybe I was overwriting it, so I changed it to this location. Wait, give me a moment. Where's my fucking linkers? We align it and we take 512 into 1024. Would that actually reach the wait, if my starting address is 0x8001234 and then locate some allocate some big chunk and then I get this. Wait, one more thing that we can do is, what is this value? What did we actually get here? This pointer value, if we can convert it into hex, we should get some information. Where's the output? Oh fucking god. Wait, I have to remove this line and write it. The fuck? Maybe I'm losing patience, so it's trying to meddle with my mind. And this is the pointer value that we are getting. Can we convert it here? I don't think we can do that. At least if we copy it. Okay, we copied it. And if we put hex of okay, this is the address that we got. And what was my chain of thought? I guess I lost my chain of thought. I was thinking about something. Fuck me. If we have it as 0, then we have to print the address allocated by this. No, the address allocated by this fucking thing. This mem block. Where's mem block called? We're calling it here. And this is what we want. Maybe that's the issue. No, at least it should give an idea of where things are in memory. Starting address. Bitmap. Okay, now let's run it again. Oh, fuck me. My fucking computer just fucking got stuck. Oh shit. Now do I have to kill it? Let's try pickle GDP. Okay, that worked. And let's just try and kill it, and this is a bitmap starting address. If we hex that, we start here. This is not bad. We so that was the issue in the previous setup, because if we are starting here, it's still B0, so it's not the issue, because we moved everything out to what, where did we move it? To something different, that is 802, so it's like a completely behind it, so we are not really overwriting anything. And we can set things as it is. It should not be an issue. Now we have the final question that's still hasn't been answered. That is, if we try to access this, we get a different okay, let's try one more thing. It's the same check, but let's see if we can make it get the L to L1 faults, because if we don't add this, we should get an L1 fault, because we have the L2 entry. At least we are back to square one. We get a fault here, we go back here, we open our kami, wait, we get L1 error, so this part is not the one that is an issue. Okay, that's good, that's a good starting point. Now we can just comment out the things one at a time and figure out where exactly which comment is fucking us. Which command has been fucking us. Where is it? What am I trying to do? QUMU. Remove that and close this. Run it. And come here, open the log, go to the error message. It's still L1. Let's just double check it. No, it's L0. So somewhere else we are getting a fucking. But if I just try to copy from anything from this file, my fucking Vims just fucking stops responding. Okay, fuck it. I'm sure it's L1, L0 error. Okay, so what we can do now is start commenting out things. We are inside K-malloc, right? No, we can do one more thing. That is, copy this and test it after. We need to find where do we fuck it up. Inside K-malloc, we allocate memory and then we do the base table entry. Let's try it here. If we get a L2 error here, then we have a good starting point. Did we come out of it? That's not good. Vast name? Wait, did I save it? I've saved it. It's 8002. Okay. 000. After rest, it's stopping. This is the rest. I'm stopping here. It should be an L2 error. Yes, it's L1 error, and it's correct. Now let's move it down to if we kill it, and if we move it down allocated, let's see what happens. If we are fucking it up at the allocation side. Oh God, help me. Why do I paste something and I get something else? Okay, total allocated is working, and then we get fucked up here. Now if we go to the log, and what's the error? It's still L1. So that's good. So allocate mem did not fuck it up. Allocate mem did not fuck it up. There's only 2 lines after that. How did we fuck it up after that? Then let's just put it in 3. Let's see if we get current index. And far VA should fail with L1 error. And we have current index and far VA failed. And if we go to QME logs, and let's go to the end, and we have an L1 error. That is good. That means even till this point we have the L1 entry. Even this point we have L1 entry. Then after that there's only one line. What the fuck? There's only one line, bro. What the fuck? Let's just copy this and paste it here and say are allocated done. For VA, and we don't have far allocated because we are in this line. And if we go to where do we have to go? We have to check the QMI logs. We still have L1 error. What the fuck is happening? Oh, it's going to fucking kill me. Because at this point we are 100% sure after our kmalloc we get an L1 error. But if I copy this and save this, and if I go to my main and I put that here, let's see what I get. It somehow changes into L0 error. No, it's still L1 error. So maybe we somehow went past that L. It's still L. Okay, that is good. Maybe I'm misinterpreting that code. That is possible because let's try it just before this line. No, there's no point in trying before this line. Let's try it here. We have the name, and if we go to QMI logs, we have L5, and the address that we are trying to access is 0000112. Okay, that's also fine. Now if I try and remove this entire thing and we just let our function do that, and if I run it, and if I kill it, and if I come to QMI logs, I get something else. What the fuck? What the fucking fuck is this? Oh, fuck me. This fucking... It's not even able to handle... VS Code is not even able to handle some big file. What's the point of QMI? Tail dash n 100. And now we can copy this. What does this? Holy fucking moly. Hey, why the fuck it's not copying? Why is this error, bro? It's translation fault 0. have doubts. How the fuck? I think it should be 04, right? Why is there 4 4? Let's copy this. Maybe ChatGPT is wrong. And it's possible. I'll just search it somewhere. See? The fault occurred during a synchronous external abort not related to translation table walk. We should not fucking believe this GPT. You fucking wasted my fucking time. I knew something else is wrong. Do we have all the code here? I think so. I had the exception code somewhere. Wait. If we go to our debugging session, not this. Maybe this. Table, no, level 1. Okay. We should get this. If we queue this to the fucking GPT, maybe it will do a better job. You fucking moron. So it is right access. Maybe write was not allowed. Translation fault 0. Well, we can do one more thing, that is we can make the starting address to be different. Let's say, where's the allocate page? Allocate mem. Find free. We go to find free. Let's start from index 8000. Halfway down the line. Let's see what the fuck happens. No, what's the error? I guess it's time to give up and try tomorrow. Okay, now we try to access this. One F400, and we didn't get any entry for it. And it says it's L1 entry. We didn't find any L1 entry for it. How the fuck it's possible? Wait. Let's just try the same thing in our example. What the crap is this? It won't copy. It's a fucking stupid VS Code. Okay. Now let's copy this and paste it here. And let's see what the fuck happens. Go to QME logs. I get 4 though. Maybe it's read, that's why it's 4. But I get errors. But when we try to do, let's see one more thing. 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. If we try this. And if we come here, we still get the same fucking error. again. Let's just put this. Because right now the errors don't seem to be. Okay, we get the same error for FFF, but we tried it like 5 minutes ago and we got 5. Something else is wrong. One, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Why is that? It's 1, 2, 3, 4. 1, 2. I can't count. My head is 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. Okay. About now. But give me logs. We get 5. Huh. Maybe it's the error is because if I give extra 4 zeros, 1, 2, 3, 4. Then I get in false. That's different. We get different error now. We are trying to do this. Let's try to build an understanding first of all. If we try to access this, let's put it here. And if we change 4 more zeros, so 3, 4, and if we go back here and try the same and come back and check the Kimi Antonelli. Dude, that motherfucker should not have let Norris pass. I think I understood the problem here. The problem is there for 3 extra zeros. My VA is 16 bits, so that address should be valid, right? No, fuck you. No, mine is 48-bit VA. Yeah, it should start from here to this point. I think accessing this fucking address is the issue. But I still don't understand it. But I get the gist of it. Why this works, but this doesn't. So how do I make my Kmalloc give out address with this range? Wait, I still need to fucking understand this thing. I don't get it. What the fuck is going on? Where is it? My fucking mind is killing me. Yeah, it's here. So we have exception if we call this address. If we don't have exception if we call this address. Both FPR address are same, right? They all have. Why are they interpreted differently? My VA is 48 bits and that address is within my VA range. Wait, let me check my VA range. No, let's see. We have an address that is this, that's faulting, and this does not fault. Oh, here the bits will be in front, it will be zeros. Here it will be FFFs. So we just have to, we just should not, our TCR is just fine. We just have to return FFFF. For that, what we can do is we go to our k-main and uncomment this, and where is our name? It's here. Go to our kmalloc. We have a VA. Where's our VA? I think this is what fucked us up. Let's see. Let's see if we got Q2 error. Oh, we didn't even save it. Okay, now we saved it. Now if we come to QUMU, Kumi logs. Yes, we have 4.5. Finally, our allocator is working. Oh no, it's not working. At least it works for the first level. God. Now we just have to fix this. So our operation was fucked up because of this simple error where I was just putting FFFF 1 2 3 4 1 2 3 4. I didn't add extra things, so it R'd it into a lesser value. Fuck me. Okay, at least we went past it. That's fine. Now it's time to fuck up. Now it's time to add our code. And if we run it, ta-da! And we got it. We fucking got it. I think it worked. If my internet, if my fucking VS Code just works. And it works. Okay, the final thing is not working. Still it's a progress. It's progress. Let's move it down here. And we only have to check one thing. That is if we actually have it. If we have it there, the memory allocation is already successful. We can think about the actual debugging later. Disassemble test me B star. No, B star is. Why is my computer slow? I don't know. Now if we one step into this and one step here, now we are supposed to be jumping to UART. Probably this is the UART call. Now if we info registers x0 and if we put xs x0, we have name and yes, then we put x1. X1 is empty. Fuck me. Well, let's try this way. 10. That is not good at all. That is not good. Let's put it here. Now we can actually see those instructions. If we run it and break into test me, continue. We didn't break, so let's kill, break into it. 1, 2, 3, 4, and continue. We break and return. Now we are actually inside that operations. We are going to do some operations, and we are doing it for whom? Let's try. What are we doing? We are setting 0 to 1. And we are setting FF. Wait. I don't understand this fucking operation. X. X8. No, X8, X9 and X10 maybe. X9 is this. X10 is... There's nothing in X10. Maybe this operation is the... There's 2. Maybe it's in top of ESP. Let's try. Now try SP. We are writing it somewhere. I just don't know what are we writing. Let's take this thing and paste it here. Explain what it does. Where's the actual buffer located? Buffer location. Memory address at SP plus 8. SP plus 8 and XP plus 16. Let's try. Access SP plus 8. This is the address. Okay, so this is the address. We have to take 16 words, so it will be this is the upper bits and this will be the lower bits. This is the full address. That we are writing into. Did I press Control C? Okay, what's the as per QME? What is the log message? It will run it again. Actually, we don't have any faults. That's the issue now. We don't have any faults right now. We are trying to figure out why that does not have a. Maybe we'll just do one more thing, that is add a /0. If we do that, my stomach is making sounds. Even that didn't work. Now I have one thing that maybe I could try is I can remove all of this shit and just put 0 and 1 and if I try this, still no, still nothing, literally nothing. We wrote something and we didn't get a fault, but when we try to read it, it's not there. What does that mean? I have no clue. Let's do the. Mm, if we try this, let's see. If we try this and build it and test me. And continue. Move W8 into whatever that is in X9. What is in X9? This is the full thing that is in X9. And X9 just does not have anything. Let's try. It has written something, but we don't see it here. It's not here, that's why it's not printing. Okay guys, this is something else. Maybe I can figure it out next time. It's time to leave. My fucking mind is not working. Thank you guys.